Hello, my dear students and the rest of the learners. Welcome to this presentation in which we are going to continue with our discussions on the topic elementary programming principles with examples using Pascal. This is part 2 of a 4-part series of presentations in this topic. The title of this presentation, which is part 2 of 4, is Program Development. My name is Memenji M, or you can simply call me Emily Swap. In this presentation, we are going to discuss on the introduction to program development, problem recognition, problem definition, program design, program coding, program testing and debugging, program implementation and maintenance, and lastly, we shall look at what we call program documentation. Let's commence with introduction to program development. Program development is a recommended series of steps followed when developing a program. Therefore, before committing oneself into writing a program, the following are the stages that must be followed. And those sequence or series of stages are called the program development life cycle, which we abbreviate as PDLC. They are: number 1, problem recognition. Number 2 is problem definition. Number 3 is program design. Number 4 is program coding. Number 5 is program testing and debugging. While number 6 is program implementation and maintenance. And number 7 is program documentation. During the process of program development, some stages have to be continuously reviewed in light of the step just before them in order to make sure that they meet the requirements. Therefore, during the process of developing the program, one should ensure that the correct requirements are identified at each stage before the next stage is initiated. Otherwise, the method of developing the program may be very expensive. Documentation is also done at all stages of the program development life cycle. This is important so that the facts are recorded when they are still fresh and in the required detail by the programmer. My dear students and the rest of the learners, it is very important to note that whereas program documentation is treated as a stage by itself, this stage is not supposed to be executed at only a specific point. This is because program documentation is supposed to be done at each and every stage in the development of a program. It is therefore advisable that you document each and every activity that you undertake at each of the stages. Therefore, program documentation is supposed to be an integrated step or an integrated activity at each and every stage. Therefore, the following diagram illustrates the program development life cycle. Just as I have said, documentation is an activity that is supposed to be done at each and every stage, and therefore, whereas certain authors or certain individuals may claim that documentation is supposed to be a step or a phase by itself in program development lifecycle, it is important to note that the best documentation is done at each and every stage in the program development lifecycle. And for that reason, I have included it at the center of the cycle. Therefore, the first step in the cycle is problem recognition, of course, followed by its documentation. Then problem definition and its documentation, program design and its documentation, program coding and its documentation, program testing and debugging with its documentation, and the program implementation and maintenance with its documentation. Let's commence with the problem recognition. This is the identification of a problem in the environment by a programmer and seeking to solve it by writing a computer program that would provide the solution after understanding and interpreting the particular problem. So, it's the understanding and the interpretation of a particular existing problem. A problem, just as I have said in the part 1 of 4 in my series of presentations in this topic, as posted on the Emily Swap ICT YouTube channel, a problem is an undesirable situation that prevents an individual or an organization from achieving its purpose and thus needs a solution. In fact, whereas people believe that a computer is a solver for most of the problems that human beings face, or whereas people think that with a computer, one can be able to solve any problem, it is important to note that it is not every problem that human beings face that can be best solved using a computer through a program. This is because there are certain issues or certain problems that can be best solved by human beings themselves instead of using a computer and writing a program to solve it. That is why the stage for problem recognition is important, because it is during this stage that one can be able to tell whether the problem at hand needs to be solved using a computer or not. To understand a problem, one has to look for keywords such as compute, evaluate, compare, amongst others. The three main situations that can cause a programmer to identify a problem that is worth solving include: number one, existence of a problem or undesirable situations that cause an organization or an individual not to achieve his or its purpose. Number two is when there is an opportunity to improve the current program. And number three is when a new directive requiring a change in the status quo is issued, for example, by the government or any other individuals that are in authority. An example of a problem is tabulating students' results in good time at Emily Swap School. What I mean, or what I want to illustrate using this example is that if, for example, you realize that in a certain institution, for example, Emily Swap School, the trainers or the teachers are not able to produce students' results on time so that the students can be able to get those results and, for example, go home with them as soon as they have done the exam, then existence of such a situation can be an indicator that there is a problem that needs to be solved or that needs to be automated using a program and more so using a computer. And therefore, if you realize or a programmer realizes that in a certain school, for example, a Melswapu school, the students always complain that they are not receiving their results in time. The teachers complain that they are not able to compute the students' results within the shortest time possible as required by the institution. Then that can be an indicator that there needs to be development of a program that can be used to automate and solve such a problem so that the students can be able to receive their results, their computed or their tabulated results on time, and thus eradicate the complaints not only from the students, but also from the trainers. The second stage is problem definition or problem analysis. This is the process of identifying exactly what the problem is by determining the sequence of instructions that are to be performed in terms of the desired output and input, processing activities and requirements, as well as coming up with a clear view of what the program needs to accomplish. The boundaries of the expected program are also established, and if several methods to solve the same problem are identified, the best alternative should be taken. My dear students and the rest of the learners, may I also emphasize at this point that whereas you might have recognized a problem in the first stage and thought that such a problem can be solved using a computer, when you do further analysis or when you carry out more definition of the problem, you may still realize that even that problem that you thought that can be solved using a computer, that it is best done or it can be best done normally and manually by the human beings. And therefore, with problem definition, you are able to gain a clear understanding of the problem and whether such a problem is worth solving using a program. At the end of this stage, one writes the requirements report or documents for the new program that enables a programmer to come up with a program design that meets the needs at hand. It is also in this stage that the programmer determines if the problem at hand can be solved by the computer or not. This stage is also referred to as the requirements specification stage. Problem specification states the function of the program. It involves the definition of inputs, transformations, outputs, and treatment of exceptional situations. Therefore, the 5 tasks that a programmer specifies are: number 1, program objectives; number 2, the desired output; number 3 is input data that is required; Number 4 is processing requirements. And number 5 is the documentation. The objective of carrying out a requirements specification, or what we call systems investigation, is to be able to describe in documentary form the essential operational requirements of the user. Out of this work comes a definition of the outputs required from the system, the inputs needed to generate the output information, the processing requirements, and the operational objectives. In order to write a program to accomplish a certain task, you must analyze the task as a sequence of instructions that can be performed by the computer. These instructions can be divided into 3 main parts, which are input and storage instructions, the processing instructions, and lastly, the output instructions. Let's look at input and storage instructions. These instructions allow information or data to be accepted by the computer. The input is information that is needed by the computer to be able to solve the problem. Ones such as enter, input, and read within a problem statement usually indicate what data the computer requires. For example, if you have a statement such as enter the admission number, KCPE mark, the student's name, and the subject is course, then such a statement can be said to be an input instruction. The input and what is to be stored in this context or in this example is admission number, the KCPE mark, the name of the student, and what he or she has scored. Processing instructions. These are the instructions which are used to manipulate the input data. They involve calculations, that is, mathematical operations, repeating instructions, selecting instructions, and comparison instructions. They also include commands and what we refer to as constructs. An example of a processing instruction is average mark is equals to total marks divided by number of subjects. In other words, this statement is a statement which says that assign the results of total mark divided by the number of subjects to the average mark. A command, on the other hand, is a word that instructs the computer what must be done in order to accomplish a specific task. Commands are specific to a particular programming language, for example, Pascal. And such commands would include write, print, read, input, amongst others. A construct is a group of instructions that work together with the commands in order to accomplish a specific task. For example, if, then, else. Problem statements that contain the ones calculate, compute, convert, add, sum, divide, percentage, multiply, average, amongst others, indicate what needs to be done. In addition, problem statements can also imply what needs to be processed by looking at what results are required for output. Example is print students meaning grade. The repeat statements and the comparison statements include, number one, comparison or selection, or what we call the decision statements. These involve determining whether a condition is true or false in order to perform a set of instructions. The second type of statements are what we call the repeat statements, looping, or iterations. These are used when a problem has to be done a number of times. Let's now look at output instructions. These instructions allow information to be displayed on the screen. Problem statements that include the key ones like print, output, display, return, and write indicate what data should be output to the screen. The analysis for the problem of tabulating students' results that I have already used would be as follows. On the side of input, we would have a statement such as enter admission number, the KCPE, the name, and subject scores. On the processing part, we would have a statement such as calculate the subject's total, the student's mean score, meaning grade, and comment. On the output part, we would have a statement such as print total marks, mean score, meaning grade, and comment. Let's now look at the program design. This is the actual development of the program's processing or problem-solving logic that is called the algorithm, which enables the programmer to come up with the modules of the expected program. The modules show the flow of events and data throughout the entire program from the time the data is input to the time the program gives out the expected information. Therefore, program design involves developing the method of solving the problem by planning and creating a solution using structured programming techniques such as top-down program design, pseudocode, flowcharts, control structures, decision tables, and decision trees. In program design, the programmer identifies the processing tasks required and the precise order in which they are to be carried out. That is, an algorithm from which the computer program will be produced. Simply put, program design indicates or involves the programmer developing a set of steps, a sequence through which the problem will be solved. That's why we are saying that its main mandate, or the main purpose of program design, is to enable the programmer come up with an algorithm that will be later translated into a program or a sequence of instructions that can then be executed by the computer to solve the problem at hand. And therefore, it is important to note that in program design, the programmer identifies the processing tasks required and the precise order in which they are to be carried out. And that's what we are calling algorithm from which the computer program will be produced. So, what is an algorithm? An algorithm is a sequence of instructions which, if followed, produces a solution to the given problem and are written using special rules and statements, of course, depending on the program or programming language that will be used to develop the code. On the other hand, a pseudocode is a set of English-like statements describing the processing steps of a program or a module. In other words, when you write English-like statements or a sequence of English-like statements indicating the flow of how the problem will be solved or indicating the algorithm to be followed, then such English-like statements is what we are calling a pseudocode. A module is a portion of the main program containing a group of processing instructions performing a specific task. My dear students and the rest of the learners, in part 1 of 4, in this series of presentations of the topic, Elementary Programming Principles, I explained what a module is, and more so, gave an example of a structured or modularized program that was computing velocity. And in that program, I had 2 modules. If you want to access that presentation again, so that you can gain clear understanding of what a module is, visit my YouTube channel by the name Emily Swap ICT and access the video by the title Elementary Programming Principles with Examples Using Pascal, part 1 of 4, by the title Introduction to Programming. Modular programming involves developing a program in form of modules, thus making it flexible, easier to read, and correct errors. A flowchart, on the other hand, is a graphical representation of the steps needed to solve the problem by using special symbols that have specific meaning and short statements. In other words, whereas pseudocode is a sequence of English-like statements that indicate how a problem will be solved. When it comes to flowchart, instead of writing those English-like statements, we replace them using graphical representations. And therefore, that graphical representation of the algorithm, of course, using special symbols, is what we are calling or we are referring to as a flowchart. Of course, this graphical representation is also accompanied by very brief, clear, and very precise short statements at each and every phase in the flowchart. Control structures, or what we call logical structures, are blocks of statements that determine the order of execution of statements in a program. At this stage, therefore, a detailed design is written which defines the following. Number one is the data structures that will be involved. That is, defining the format and type of data that the program will use. Number two is designing the user interface. That is the design of the screen the user will see and use to enter data or display data. Number three is designing inputs. This is defining the kind of data to enter into the program. Number four is designing the outputs. That is, the possible data to be displayed from the system and how it will look like. That is its format. Number five is the algorithms. That is the methods of calculating outputs depending on the inputs. The next step or stage in program development lifecycle is program coding. This is the actual process of writing the instructions using a particular programming language to develop a source program that can be translated into machine-readable form for the computer to execute and solve the target problem. It involves typing the instructions into a program editor window into the computer in order to tell it how to solve the problem, and a certain programming language is used. In other words, once the systems analyst or the programmer is through with designing the problem or designing the program by developing clear algorithm, then the next step, which we are calling program coding, is where the specialist or the programmer converts the design given into a set of instructions or code using a certain programming language of choice. And therefore, if you give, for example, a set of programmers the same program design, then these programmers have the freedom to decide which programming language to use to translate that design into its respective code. For that reason, whereas many programmers may use various programming languages to translate that design to a code, at the end of the day, all those codes will be solving the same problem and in the same way because they are all using the same design. For that reason, each programmer is usually free to use the programming language of choice that he or she is very good at in coding the program based on this design given. However, certain programming languages are very good for solving certain problems. It is therefore the responsibility of the programmer to make a decision of the language to use based on the type of problem that he or she has received design for. Programmers use the program specification and design to write the code necessary to fulfill all the requirements of the program. The code is a text-based file which, when compiled, creates the program. A good programmer will therefore consider the following. Number one is the future maintenance for the program to be developed. So, in this case, any code that may be modified in the future should be allowed for when writing the code. Number two is code readability. This enables programmers to identify areas of code quickly and easily, regardless of the length of the code or regardless of the number of pages that the code will have taken. Number three is debugging. Virtually all programs have defects in them which we call bugs, and these need to be eliminated. Bugs or errors can arise from those errors in the logic of the program specification or errors in the programming code created by the programmer. Special programming tools assist the programmer in finding and correcting the bugs. So when we talk about the coding, we are simply referring to the actual process of converting a design model into its equivalent program. Converting the algorithm to the programming language requires the use of specific syntax of that programming language. This is purely because each programming language has a certain syntax. It has certain rules that have to be adhered to when developing that source code so that the translator for that language can be able to effectively translate that language to a form that the computer can understand. My dear students and the rest of the learners, if you want to gain more information concerning what is syntax, what is source code, what is object code, what is programming language, kindly listen to my part 1 of 4 of presentations in this topic in the video that is already posted in Emily Swap ICT YouTube channel by the title Elementary Programming Principles with Examples Using Pascal, part 1 of 4 on Introduction to Programming, or simply on Introduction to Programming. In converting the design to a program, there are a number of general points and techniques that are important and are applicable to any programming language that you might use. These are following the code standards to write a program, ensuring that the program written is readable, and selecting a program generator to use in creating reports from the program. What is coding standards. The two main functions performed by programming are, number one, creation of programs. In this case, there is initial writing of code and subsequent checking and amendments so that it performs the required functions. Number two is maintenance of existing programs. In this case, the programmer makes changes and adds any features that are required. And therefore, standards in programming aid communication between people working on the same project and increase the interchangeability of people of different aptitude, abilities, and experiences within and between different projects. So, it's always good to code a program in such a way that one can easily tell what each part is doing, even if he or she was not the one who coded it. Let's now look at a readable program. The readability of a program is more important than the intricacies of the code. Some rules for creating meaningful data names are: number one, always use names that are meaningful. For example, cost price plus VAT is equals to selling price. My dear students and the rest of the learners, when you are using more than one word to refer to something or to refer to a data name, you use an underscore if you want to join more than one word to be treated as a single name or a single variable. So, under the rules of naming variables, if you have to use more than one word to refer to something or to refer to a variable, it is advisable to use an underscore in between the ones. For example, cost price. That symbol there is an underscore, not minus. This is because if it was written as cost minus price plus VAT, that meaning would automatically change. So, in terms of variable names, it is cost underscore price. That is one word. So, some rules for creating meaningful data names are: number one, use names that describe the purpose of the code or variable. Secondly, don't make up aliases. Number three, don't use names that are similar. Change at least 2 letters. Number four, always keep spellings as normal as possible. For example, student underscore name, that is student name, instead of ST name. Number five, use the same prefix for all the variables in one record or the local variables in a subroutine or a module. Let's now look at comments under the coding. Comments are those statements that are inserted in a program code to help make the program code more understandable. Comments should be added at the module level to explain the purpose of the module and within the code in order to explain complicated algorithms or highlighting error-prone sections of the program. My dear students and the rest of the learners, for you to be able to remind yourself on how to add comments in a code, visit MLSwap ICT YouTube channel and access part 1 of 4 of these presentations in this topic, and then you go to the section for high-level programming languages and especially and the structured programming example given there. You will see a Pascal program that I have used to illustrate what a modularized program is all about, and then you see how I have integrated various comments within the various parts of that program. It is good to include these unexecutable statements within the code so that anyone reading the program can be able to understand its purpose, and will also help the programmer to understand it after a period of time has elapsed. Number 3 is indentation. This is arranging lines of code in a program in such a way that one can easily reflect or see the logic structure of the code. It is advisable to always place only one instruction on each line and make sensible use of black lines and new pages to keep code readable and limit components to a manageable size. Number 4, avoid the tricks. Always make sure that the program is written using straightforward code which people can readily understand. Number 5 is modularization. This is splitting up a program to make it easier to understand. It also reduces the effort required later to change the program, since changes only need to be made to the module whose functionality changes, or if a new feature is to be added, then a new module can be added. Testing and debugging also becomes easier with small independent modules. So what are the basic rules for creating modules? Number 1, each module should contain only one program function. Number 2, the maximum size for each module should be about 100 instructions. Number 3, there should be only one entry point and one exit point in each module. So the two main methods or ways or designs of coding programs are monolithic and structured. What is monolithic? Monolithic is a situation where a program or a design where a program consists of a sequence of individual instructions that are executed one after the other. This results to a one massive program consisting of several thousands of lines of code that are grouped in any logical way. The main disadvantage of this style of coding is that maintaining such a program is time-consuming and expensive, since changing even one line of code could affect the entire program. Number 2, any conditional branching forces the program control to jump back and forth, thus creating tangled loops, which we call the spaghetti loops, that make it very hard to even trace errors in such a program or even understand the functionalities of that program. It is therefore advisable to avoid monolithic structures or monolithic design and adopt other designs such as structured. So what is structured design? This is breaking down a large program into smaller, understandable chunks, with each performing a specific task. This makes long and even complicated programs easier to code, understand, and maintain. So, the amount of code that a programmer has to deal with for any one module is much less than dealing with the system as a whole. What are the advantages of modular programming? Number one is able to reuse modules that contain standard procedures throughout the program, saving development time. Number two, testing of individual modules in isolation makes tracing mistakes easier. Number three is that amendments to a single module does not affect the rest of the program. Number four, such a program, or in such a program, one has the ability to create libraries of often used routines which are reliable and can go into other programs. Number five, modules can be named in such a way that they are very easy to find in documentation and that are consistent. What is top-down approach? This is the process of breaking down a large program into smaller and manageable components. This process continues at each level until there is sufficient detail to allow the coding stage to proceed. An outline program is designed first, showing the main tasks or components of the program and the order in which they are to be executed. The process of reducing components into sequences of smaller components is referred to as stepwise refinement, and it forms the basis of structured programming. The top-down approach allows a program to be designed methodically by providing a complete definition of the program at each level of complexity. Let's now look at what we call the program generators or report generators. This is a software utility which has been specifically designed to make the task of creating reports fast and easy. Generators produce a program which will create the defined output from the preset specification. Most application development on database systems use form and report generators to facilitate the task of creating forms and reports, thus reducing the amount of time and effort which is required to build applications. What are the qualities of a program? A good program has the following characteristics. Number one is accuracy. A program is supposed to do what it's supposed to do and meet the criteria that is laid down in its specification. Number 2 is reliability. A program should always do what it was supposed to do without crashing. The main difference, my dear students and the rest of the learners, between accuracy and reliability is that when we speak about accuracy, we are simply saying that the developed program should be able to meet the criteria that it was intended to meet. When we talk about reliability, we are simply saying that a program or the same program should always be able to produce the same results without any changes, unless if those changes have been introduced by the programmer. So a program should always do what it was supposed to do without failing. That is also another aspect of reliability. I repeat, when we speak about reliability in relation to qualities of a program, we are simply saying that the program should always perform the intended task without failing or without crashing. But when you talk about accuracy, we are saying that a program should always generate the intended results or results that have no errors. That is correct output. Number 3 is efficiency. A program, or there is a situation where a program using the available storage space and resources in such a way that the system's speed is not wasted. In other words, we say that a program is efficient if it is able to make use of the available storage space and the available resources without wastage. Number 4 is robustness. In this case, a program should be able to cope with invalid data without creating errors or stopping without any indication of the cause. So, when we talk about robustness as a quality of a program, we are simply saying that the program that has been developed should be able to cope with any invalid data that may be made by the user without creating any errors or stopping without an indication of the cause. Number 5 is usability. This is a situation where a program is made in a way that it can be easily understood by those who are using it because it is also well documented. So a program is said to be usable if it is easy to use and is well documented. Number 6 is maintainability. A program that has been developed should be one which is easy to amend because it has good structures and also good documentation. The 3 main goals of structured programming are: number 1, it decreases programs development time or to decrease programs development time. Number 2 is to decrease program maintenance costs. Number 3 is to improve the quality of the software. So those are the main 3 goals of developing structured programs or for engaging in structured programming. The next step, which is stage 5, is called program testing and debugging. This is finding out whether the program coded is working correctly and verifying errors if detected. And not only verifying, but also correcting. And therefore, program testing and debugging is that process of finding out whether the program that has been coded is working correctly and rectifying errors if detected. Rectifying errors if detected. Rectifying errors is what we call to debug, to rectify errors. Debugging is therefore the process of finding any types of error or bugs and correcting them. A bug, on the other hand, is an error in a program that may interfere with its operation. So, program testing involves creating test data designed to produce predictable output. The 3 types of errors that can be encountered while testing a program are syntax errors, semantic or logical errors, and runtime errors. What are syntax errors? Syntax, just as I said before, is the structure of a sentence and the grammatical rules concerning the structure. And therefore, a syntax error is an error in the grammar of the programming language. This is in terms of spelling, punctuation, naming of variables, and other conventions that must be obeyed by the programmer while using a certain programming language. It is important to note that syntax errors depend on the language in use, because each programming language has its own specific syntax. So syntax errors are detected by the translator and must be corrected before the program runs. An example of syntax error in Pascal is right line answers are X, Y, Z in mouse. Why is it a syntax error? It is a syntax error, or the syntax error in this statement, because this statement begins with the command right line, which is not known by Pascal. Why? Because right line does not have E at the end, nor does it have I. But in Pascal, it's supposed to be written as right line. That is W-R-I-T-E-L-N and not W-R-I-T-E-L-I-N-E. And therefore, the correct syntax is supposed to be right line with LN, bracket, opening inverted comma, answers are X, Y, Z in mouse, closing inverted comma, bracket, then semicolon. Let's now focus on the semantic or logical errors. These are errors in reasoning, such as incorrect sequencing of instructions and flawed comparisons and selection statements which makes the program not to function as expected by producing incorrect results or causing program to be aborted during program execution. Lexicon is a dictionary of valid ones in a language, and semantics is the meaning of ones and sentences. The logical errors don't stop the execution of a program, but the results may be inaccurate and can only be noticed and corrected by the user himself or herself. They are not detectable by the translator. For example, numbers might have been subtracted instead of being multiplied. Therefore, a logical error can lead to one of the following two results. Number one, the program will produce wrong results, but will finish normally. Number two is an unusual condition will be encountered that leads to a premature end of the program. What are runtime errors? These are the errors that occur after the program has been tested and debugged, and they occur during the execution or running of the program. They occur, for example, if the program is stuck in an infinite loop, or it runs by repeating and repeating itself without ever terminating. These errors stop the program from continuing execution because of wrong type of data being entered. Once an algorithm or a program is developed or written, the next stage is therefore to check that the algorithm or the program is doing what it was designed to do and is also doing the same in the correct manner. The two main types of testing are manual, or what we call dry running or desk checking, and computer testing. Computer testing includes translator system checking, running program with the test data, using diagnostic procedures, and system tests with actual data. The following are the several stages and methods used in testing the data. Number one is what we call desk checking. This is also called tracing, manual testing, or dry running. This is a technique of going or reading through the program while it is still on paper before entering it in the program editor so as to detect any obvious syntax or logic errors in the program. Tracing involves executing the program manually by using input values for variables and recording what takes place after each instruction is executed. A trace table is a table which is completed upon manual execution of an algorithm in order to determine what the program is doing. The first action when creating a trace table is to write down all the variables found in the algorithm as headings, as well as the heading output to represent what is printed. The other method is translator system checking, or attempt at translation. The translator is used to detect any syntax errors. The programmer corrects those errors and resubmits the program until an error-free listing is obtained. The program is thus run through a computer using a translator program. Number 3 is program run with test data, or what we call testing sample data. This is carrying out trial runs of the new program using various data variations and extremes of even data with errors so as to test whether the system will grind to a halt or it will inform the user about the abnormality and request for the entry of the correct data. Testing data is also used to verify that the program is doing what it was supposed to do. The program should be tested using suitable test data. If you test using only meaningful data within a well-defined range, you would be assuming that only valid data will be used in the program, which is not normally the case in a normal working environment. And therefore, the data used for the testing must be chosen to deal with all eventualities and should also include extreme data, that is data outside the range, as well as data within the range. A good program should therefore not crash due to incorrect data entry, but should inform the user about the anomaly and request for the entry of the correct data. The 3 general categories of test data, therefore, are: number 1, the normal data. This data includes the most general data for which the program was designed for. Actual data is used to check for the actual results. The second category is extreme values. These test the behavior of the program when valid data that is either too high, that is upper limit, or very small, that is lower limit, is used. Number 3 is what we call the exceptional data. This is entering illegal data that is not within the range or class of inputs in order to see if the program is capable of rejecting it rather than attempting to process it in order to avoid getting wrong results. Number 4 is using debugging utilities, or what we call the diagnostic procedures. This is running diagnostic procedures such as trace routines during translation in order to detect syntax or logical errors in order to correct them before execution. A trace prints out the results at each processing step to enable errors to be detected quickly. If a trace is not available, the programmer can insert instructions in the program to print out intermediate results at the key points. Number 5 is system test with the actual data, that is testing by users. This is a very important part because as part of the acceptance trials, the new programs are usually run in parallel with the existing system for a short time so that results can be compared and adjustments made. The system test is made using actual data. The 6th step or stage in program development is called program implementation and maintenance. When we talk about implementation, we are referring to the actual delivery and installation of the new program ready for use, and training the users for the system that has been designed. Review and maintenance is also important because the errors that may be encountered after the program has been implemented or exposed to extensive use. Maintenance, on the other hand, is ensuring that the current programs are operating error-free, efficiently, and effectively. A program may fail due to improper use, hence proper training and past implementation support of users will reduce chances of having them entering invalid data that crash the program. In maintenance, the programmers update software to correct the errors, improve stability, standardize, and adjust to organizations' changes. A common practice is to run the new system in parallel with the old system in order to ensure that if something goes wrong, the business does not come to a grinding halt. After a number of successful parallel runs, the old system will be abandoned and the new system will become fully operational. At this point, the system goes into the final stage of monitoring and review or evaluation, where the performance of the system is evaluated with reference to the initial requirements. After a new program has been implemented and has been in use for some time, a new need may arise due to a new problem, a new directive, or a new opportunity, which may still make an analyst discover a need for a new system or a modification or a complete overhaul of the entire program. This restarts the program development lifecycle. The other step, which I have said that it is normally an integrated step amongst the other steps or phases, is program documentation. This is writing of support materials explaining how the program can be used by users, installed by operators, or modified by the programmers. And documentation is a document showing what a program does and it can work under what conditions. It is a written explanation of how the program works and how to use it. All the stages of a program development should be documented in order to help during future modification of the program. The purpose of documentation is therefore for communication, quality control, and reference. Poor communication between the people involved in the development of a system can cause major problems, as the information passed from one phase to another may become distorted. Documentation is therefore an integral part of the inspection process. It ensures that the intentions of the originator of the system survive from specification to design and from design to coding. The main functions of documentation, therefore, are: number one, helping you maintain the system. Number two, if you want to do some changes, that is modify the program, you can know where those modifications can be made. Number three, it is easy to update the program because any changes that you want, any improvement that you want, to make into the program can be made easily. So, the 8 main advantages of program documentation are: number 1, it is easy to know the purpose of each part of the program. Number 2, it is easy to know the process of the program and others can follow it. Number 3, it consists of written descriptions and procedures about the program, thus enabling the user to know how to use it. Number 4, it is easy to know under what conditions the program works. Number 5, it helps one maintain the system. Number 6, if you want to do some changes, you can know where they can be. Number 7, it is easy to upgrade the system in order to solve the arising needs. Number 8, documentation helps the user work with the software with minimal guidance. Generally, we have 2 main methods of writing documentation. These are internal documentation and external documentation. When we are referring to internal documentation, we are referring to the methods that are used when coding a program in order to make it readable and help other programmers to understand the code statements. These include indentation and spacing that help to easily identify the sections of the code in a program. Number 2 is comments. These are the explanatory non-executable remarks that are written within the source code in order to help the programmers understand the code statements. Number 3 is suitable variable names. The names used should be associated with what is being stored so that further explanation is not needed. The other one is external documentation. Remember, I have said that internal documentation is normally done within the code. What about external documentation? These are the reference materials such as user manuals and the tutorials that are printed either as booklets or recorded in storage mediums in soft copy explaining about the program. The documentation for a simple program generally fall into 4 sections, which are identification, general specification, user information, and the program specification. These are always included in the documentation for a program. What is indentation documentation, or what is identification in relation to documentation? This should include the title of the program, short statements of its function, the author, date written, language used, and the version if relevant, and the hardware requirements. Number 2 is general specification. This should include a description of the main actions of the program under normal circumstances, the file specifications, restrictions and/or limitations of the program, and reference to any texts explaining any complex procedures or techniques used in the program. Number 3 is user information. This should include the format of input required. For example, source documents, how to produce outputs, and their layout, and detailed instructions on how to run the program. Number 4 is program specification. This will contain the design of the program using structure charts or flow charts, annotated diagrams listing and testing procedure including test data and expected output. Then, how many types of documentations exist? The 3 types of documentations are user documents, or what we call user-oriented documentation, operator-oriented documentation, and technical documentation, or what we call the programmer-oriented documentation. So in other words, there's documentation intended for the user. There's documentation intended for the operators, and there's documentation intended for technical support, such as for the programmers. Let's look at each of them, beginning with user-oriented documentation. This documentation is written to explain to the user how to use the program, thus enabling him to learn how to use the program as quickly as possible and with little help from the programmer. It is written in plain English and not in the technical programming language of technical documentation. It includes hardware requirements, how to install the program, how to run the program, how to enter data, what the output looks like, how to use any menus, special features of the program, error messages, and advice on how to correct them, that is, troubleshoot any errors. The second documentation is called the operator-oriented documentation. This documentation helps the computer operators to install and maintain the program. It is meant for computer operators, for example, technicians. The other documentation is programmer-oriented documentation. It is written for skilled programmers. It provides necessary technical information to help in future modification of the program. In this type of documentation, all stages of the program development should be documented because, number 1, there may come a need to revise or modify the program. Number 2, other programmers may think of ways of improving your program. Therefore, technical documentation is a documentation used by programmers to be able to know what each section of the program does and how it works, so as to be able to maintain the program, know which part needs to be modified, and be able to update the program. Some of the reasons of technical documentation, therefore, include, number 1, the programmer needs to understand what was written a few weeks or even months before when writing a long program. Number 2, extremely large programs are written in teams, where certain teams write particular sections of the program code. Each team, therefore, needs to understand what the other teams have written so that the whole thing can be fit together. Number 3, is to help a new programmer to be able to read and understand the written program so as to help him to revise it to fit a new situation, modify it, or correct it for logical errors that may show up after using extreme data. Technical documentation includes the problem that the program is intended to solve, that is the purpose of the program. Number 2, the algorithm. Number 3, the program code or listing with its internal documentation. Number 4, its test data and results produced by the program. Number 5 is data and file structures. Number 6 is the structure and flow diagrams which show the relationships between the program modules. So the 3 targets of documentation are users, operators, and programmers. We have now come to the end of part 2 of 4 of this series. You can now proceed to listen to part 3 of 4 on the topic or on the title, Development of Algorithms. Congratulations for learning part 2 of 4 in Elementary Programming Principles topic. You can access part 3 and part 4 of the topic, as well as other computer or ICT videos by clicking or tapping on MLSwap ICT YouTube channel below this video if you have not already done so. You can also visit the other YouTube channel by the title or by the name MLSwap Life Skills YouTube channel so that you can be able to access free life skills, motivational and inspirational resources. In order for you to subscribe to this channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. In other words, if you have not subscribed already. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and let's meet in the next presentations, part 3 and part 4 of this topic in the same YouTube channel, that is MLSwap ICT YouTube channel. May God bless you, and thanks for listening to me.